Hello students, welcome to Edison. In this problem solving video, we are going to solve the recurrence relation using a recursion tree method. Okay, so using a tree, we have to solve it. First of all, we should know what are the cost. Previously, we have set the cost as some constant. Here, we kept the constant. We are removing the constant. We use n as a cost here, and this otherwise when it is written you should know the if condition is written if n is greater than 1, otherwise condition could be if n is less than equal to 1. So we have two options, if n is less than 1 or n equal to 1. Okay, in this case better we should say uh, that 1 or 0 are the just a constant for us, or you can say it could be n less than 0, or you can say n is equal to 0. These are just a constant for us. So better we can say the base condition whenever you are finding, we can say the base condition could be if n equal to 0. If n equal to 0, the base condition is written here. Okay, and n equal to 1 also you can write, but better we can say whenever like the decreasing function is written, that we should use 0 to equate it in a proper way. Okay, next we should carry on then. The question is written t of n equal to 2 into t n minus 1 plus n. This is the question given to us. Now as per the tree method, we should have to write the cost for the first site. Before that, we should have to change it, like the number of, I must remove that one. Here I should write number of children, per level. Next is cost per each level. First of all, we have to decide this one. Next, we started with the first cost. The cost is n initially, and there are two n minus 1 we are generating. Okay, n minus 1, n minus 1. First of all, we have to uh, say there are two different cost we are generating, n minus 1, n minus 1. Okay, now from n minus 1 also, those who are new, kindly check the previous problem solving videos, as well as there are detailed videos based on the uh, recursion tree method. You can visit that one too. So whenever we are getting this n minus 1 again, we are having this 2 multiplied there. So in recursion, you can say iteration, whenever we are finding tn, the question is tn minus 1 plus n. Whenever you are finding this one also, tn minus 1, you put the value inside n, you will get the value t into n minus 1, again minus 1 plus n minus 1, because in place of n you are putting n minus 1. So 2tn minus 2 plus n minus 1. This is what you are expecting. So 2 times again you are getting the cost as n minus 1. This is what we got. This is what we have written. Okay. So next is this tn minus 1 will be again subdivided into two different children node. Okay, next it could be like n minus 2, n minus 2. Okay, if you do further segregation of it, it could be n minus 3, like 2 times n minus 3, again 2 times n minus 3, and n minus 3, here also n minus 3, n minus 3. Okay, so you stop for a while because you know like what will be there. So here in level 0, there is one children node. Okay, so better I am writing it here. One children node means 2 to the power 0. At level 1, it could be 2 to the power 1, which is 2 you are getting. Like 2 number of children you are getting or child nodes you are getting. In level 3, it could be like 1, 2, 3, 4. 4 means 2 to the power. At level 2, you are getting 2 to the power 2. At level 3, you are getting 1, 2, 3, 4, 5, 6, 7, 8, which is 2 to the power that level only. 2 to the power level is equivalent to the number of children nodes you are expecting. Okay. Suppose you are running for k times you are running, and that k times you are reaching somehow the base condition, because we have studied we are reaching the base condition, like we have reduced the time complexity, and we know we are compatible with that because we know the maximum time complexity we can find out if we relate with the basics ones. That is there in a detailed video, kindly watch that one. So here the cost will be just equate as 1 as n, because no such cost are there. So here we are going to add this one, like n minus 1, again n minus 1 is to n minus 2. I must have to give certain space for the equations. 2n minus 2. Next here is 1, 2, 3, 4, 4, n minus 8, because 2, 2, 4, 6, then 8. Here it could be like 3, 4, 5, 6, 7, 8, 8n minus 6, 4 are 24. Okay. Now you stop for a while, you try to find the pattern. As we discussed, like we are finding the pattern first. The pattern could be, this type of pattern is going to be built. Okay. So the number of practice are actually needed while you are finding the pattern. You have to check, because 2 to the square why I'm taking, because 2 to the power something we are taking for the reason of k times if it is running, then what should we expect for it. Okay, the expectations. So finding the expectations only, we are just running for 2 to the 3, then n minus 3 could be the better answer, because 8 into 3 is 24 and 8 into n is 8n. Okay, we are basically trying a pattern, we are finding the pattern. Okay, so here if you are running this one, the pattern could be 2 to the k n minus k. This is what our expected pattern would be for level k. For level k, we can expect the children could be 2 to the power k, and here we can expect the cost could be this much. Okay, now once we found out with this answer, our first target is to find out ci, which is the cost of intermediate nodes, or you can say better we can take assumption we reached somehow. For this case we can say it's n minus 3 n minus 3, so we can say Tn minus k, as we have equate with t of 0 now. Clear? So then what we have to do, because n minus k, why we are writing, because at level 1 we are writing n minus 1, and level 2 we are writing n minus 2, at level 3 we are writing n minus 3. For that reason at level k it could be n minus k. Okay, so we are taking assume that we have reached the base condition. We have reached a base condition. In that case, Tn minus k equal to t of 0, where the cost would be equal to the cost, where k equal to n or n equal to k. Okay, not an issue. Next is, now we have to find out CL or Ci. Any of this could be found out, not an issue. First you can find out C of I, not an issue. Ci, I must write it, sum of all intermediate nodes could be written as C of I. C of I is, first is n, then it will be added with 2 n minus 1. Next, 2 of 0 is 1 and n minus 0 is n, so it is by default n, so that is why I'm writing it. Okay. Next, to find a pattern, I'm just checking that one. N minus 2, we can say n minus 3, then we are just writing it 2 to the power k n minus k. Okay. Next thing is n plus 2 n, then 2 square n minus 2 plus 3 n minus 3 plus 2 to the power k minus 1 n k minus 1, because before k there is some value, that's why we are writing it n minus k. I must write it k n minus k. Next, n plus 2 to n minus 1 plus 2 square n minus 2. It would be like to n minus 1. I'm just putting the value, substituting the value. N minus n plus 1 plus 2 to the power n, n minus n. I'm just substituting the value. Value of k. Substituting the value of k, that's why you are getting this answer. N plus n minus 1, 2 square n minus 2 plus 2 to the power n by 2. It's minus 1, so that's why I'm doing this one. Or else you're keeping this, that could be better. N minus 1. Here n got cancelled. I'm just writing 1. 2 to the power n. I must say this 0 will be multiplied with the value, it will be 0, but 2n minus 1, up to that we can expect the answer. So here approximately it is not 2 to the power n exactly. We can say, if you are writing this 2n minus 1 plus 2 square, we have to assume some answers for a while. 2 to the power n by 2. So here up to this, if you are finding out, no? So the maximum you are getting is 2 to the power n. With whether you are getting 2 to the power n, the expectations which you are saying, it could be 2 to the power n. You have to take assumption. Why? Because the maximum is 2 to the power n. 2 to the power n is exponential. Why? Because constant to the power n we are writing. That's why we have taken some assumption which is not equivalent to this to the power n, but though we are dividing with the 2, somehow it is just little bit difference to the original one with the expectations. Why? Because we cannot say 19 is equivalent to 20. We cannot say it, just a little bit difference. Okay. Why? Because it got divided by 2. The maximum which we picked is got divided by 2. Now the next answer would be cost of leaf node. When we are finding cost of leaf node, that will be C of L. Okay. Now C of L will be the the children at level k is 2 to the power k, and the cost of each level, key cost of each is the cost of t of 0. Like you reached at the base condition, that is 0. You cannot say the answer as 0. It is wrong. Here the 0 is a constant. So constant multiply with the biggest value, we must write that value. Okay, we are not exactly writing this one because this is not a mathematical formula. It's a constant we are multiplying. You can say if 2 to the power k into constant equal to 2 to the power k, because 2 to the power is a greater value. Okay, so you can substitute the value of k, then the answer could be C of L will be 2 to the power n. Okay, Now here I am writing this is C of I. Next, we can write time complexity. Time complexity will be C of I plus C of L, which is 2 to the power n plus 2 to the power n. You can say it could be better, we can write 2 to the power n. Just 2 into 2 to the power n is equivalent to 2 to the power n, and 2 into 2 to the power n we are writing it. Okay. Next is, suppose you are using master method to verify that. Master method, in master method we can say A is, as per this example, T of n equal to 2 into Tn minus 1 plus n. So here uh, A is 2 and B is 1, K is 1. Why? Because this is A and this is B and this part is K. So as per the formula, we can say if A is greater than 1, we can say it is case 1. So here 2 is greater than 1. That is why we can say case 1. For case 1, we can write A n to the power B into f of n, and f of n is not written here. So f of n is 1 by default. We can say the time complexity could be rewritten as, we go of A is 2, n by B, n by B is n by 1, we go of 2 to the power n by 1 into 1. Why f of 1 is absent now? The time complexity would be 2 to the power n now. So we are getting the answer through the master method also. Okay. So the time complexity we can get is 2 to the power n in that way, also in this way. I hope it is clear to you. If any doubt, you can comment below. Not an issue. Have a good day.